Welcome to SK Eduvers, your learning space for engineering, AutoCAD, mechanics, tutorials, and beyond. If you found these videos helpful, don't forget to like, share, and subscribe to the channel, and press bell icon to stay updated with all upcoming tutorials. In this video, we are going to understand the principle of isometric projection, one of the most important topics in engineering drawing. Isometric projection is a type of pictorial projection in which three dimensions of solid are not only shown in one view, but their actual sizes can be measured directly from it. If a cube is placed on one of its corners on the ground with a solid diagonal perpendicular to VP, the front view is the isometric projection of the cube. In isometric projection, the object is oriented in such a way that its three mutually perpendicular edges are equally inclined to the plane of projection. Here you can observe BC, CD and CG. These are the three mutually perpendicular edges are equally inclined to the plane of projection. The step-by-step construction is shown here. We'll see. To draw the projections of a cube resting on the ground on one of its corners with a solid diagonal perpendicular to the VP, assume a cube to be resting on one of its faces EFGH on the ground. See here the solid diagonal EC is one solid diagonal I have drawn here, and AG also another solid diagonal. Similarly, we can have two more solid diagonals like BH and DF. So here, so I considered this AG and EC. So finally we are going to deal with the solid diagonal EC. The point's position also you can observe exactly below the point A you can find the E, and below B point F. G is below point C and H below point D. ABCD is the top base and EFGH is the bottom base, and EC is one diagonal solid diagonal, AG is another solid diagonal here. So now draw the square ABCD in top view with its sides inclined at 45 degrees to XY line. The line AC, you can see here, the line AC representing the solid diagonals AG and CE is parallel to XY line. Now obtain its front view. So this is the front view we are going to get, which is resting on the ground. So it comes on XY line, its base EFGH. So for construction purpose, so this is the solid diagonal which is drawn here, EC, and this line is perpendicular to EC. The second stage, tilt the front view about the corner G, that is G dash, so that the line EC becomes parallel to XY line. This EC line becomes parallel to XY line. Now project the second top view. So the solid diagonal CE is now parallel to XY. That means CE is now parallel to both HP and VP. In the front view you can see EC or CE is parallel to XY line, that means parallel to HP. In the top view you can see CE is parallel to XY line, that means parallel to VP. Now reproduce this second top view so that the top view of the solid diagonal EC is perpendicular to XY. Then project its front view. This is the final front view in which the solid diagonal EC is representing by a point, that means the line is perpendicular to VP and parallel to HP. So this is the final front view of the cube, so which is in isometric position. If you observe this picture carefully, the planes ABCD and CGHD BCGF, so these are the planes mutually perpendicular to each other, and in this picture all these are looking similar rhombuses, and the edges of the cube CB, CD and CG. So these are called the isometric axis, and the other edges parallel to these are called the isometric lines or isometric edges. Now that we understand the basic principle of isometric projection and the orientation of cube, so further let us proceed step by step and draw the isometric projections accurately with the planes as well as the solids. Here you can see the angle between these two isometric axis is 120. Also the angle between these two isometric axis is 120, and here also it is 120 degrees. If I draw a horizontal line at this point, see, with respect to this horizontal line, this isometric axis making an angle of 30 degrees. That means this horizontal line is obviously perpendicular to this vertical. So here it is 90 degrees. Right, 120 minus 90, that is 30 degrees. So similarly this side also it comes 30 degrees. So in this picture you can see the top plane ABCD. So this is we consider generally parallel to ground or ground plane, and remaining two isometric planes CDHG is vertical plane, and another plane BCGF. This is also we consider as vertical plane. So whenever it is required to draw the objects in vertical plane, we have to take either this side plane or this side plane as base plane and then proceed for the further construction. Suppose if any object is placed on the ground, then we have to consider this top plane ABCD. The same way we have to construct in the isometric projections. Thank you.